60 valid runs, 60 passes, 0 human corrections, 0 critical errors. I expected an AI planner to miss a filter, edit the wrong record, or give up when a form rejected its input. It did none of those things. But this is not proof that browser agents have solved the web. The test ran inside a controlled synthetic laboratory, and the planner did not receive a native browser connection. A coordinator operated the visible browser as a literal proxy. The most revealing mistake was not made by the AI. It was made by my test environment. Here is exactly what passed, what 100% means in this benchmark, and why I still would not give an unsupervised agent access to a real business account. I built a local website that behaves like a small operation system. It has customer records, support requests, inventory, projects, and forms for contacts, requests, and follow-ups. Every name, date, note, and identifier is fictional. The site cannot send a real message, spend money, expose a private account, or change production data. A reset button restores the exact frozen dataset before every run. The model was GPT-5.6 Sol at high reasoning, used as a blind planning agent through Codex. The scored runs were completed on July 24th and 25th, 2026, in Chrome 150. The research question was narrow, across 20 controlled browser tasks, repeated 3 times each. How often could this planning setup reach the correct answer or persisted end state without a human hint or correction? That creates 60 valid scored slots. The 20 tasks were balanced across 5 families. Navigation and retrieval meant finding a specific record and reporting 1 visible field. Form completion meant creating fictional contacts, requests, or follow-ups with exact values. Filtering and sorting combined multiple constraints, such as owner, status, priority, or due date, then asked for the first resulting record. Multi-step state tasks changed several fields on 1 exact record and required a confirmation dialog before saving. Recovery and ambiguity were designed to catch confident shortcuts. 2 customers began with the word Aster. Similar controls appeared on the same page. 1 email was deliberately invalid. Some tasks required preserving a nearby record while changing another. Before scoring began, I froze the wording, expected answers, end state validators, a 3-minute limit, and a reproducible randomized order. The scored planner could see only the task instruction and the current visible accessibility snapshot. It did not see the source code, expected answer, validator rules, pilot notes, or previous results. Fresh agent contexts could not access the browser backend directly, so I used the contingency written into the protocol, a coordinator-operated visible browser proxy. The blind planner requested 1 action at a time, such as click requests, choose owner, select Leo, or fill the note field. The coordinator executed that action literally. It provided the next visible snapshot or a literal browser error, but no suggestion, correction, optimization, or hidden ground truth. Every interaction target also had to resolve to exactly 1 visible element before the action executed. The validator stayed hidden until a 5-run block ended. For retrieval tasks, it checked the reported answer. For state-changing tasks, it checked the persisted server state, not the planner's claim that it had finished. This arrangement tests planning from visible interface state. It does not measure native browser control speed, and I will return to that limitation. The easiest family was navigation and retrieval. Its median orchestration time was 32.5 seconds. In 1 task, the planner opened projects, found beacon launch, and reported August 4, 2026. In another, it filtered projects to active, sorted due dates from earliest to latest, and returned P306 from the first visible row. The important detail is that the final answer was not accepted because it sounded plausible. It was compared with the frozen answer key. Forms took longer, with a family median of 64 seconds. The planner had to preserve exact spelling across names, dates, companies, roles, and notes, then wait for a visible created record status. None of these tasks is impressive as a one-off demonstration. Their value comes from repeating the same frozen task 3 times and scoring the end state every time. The recovery tasks were more interesting. 1 instruction explicitly said to try the invalid email NIAT, then recover with nia.torazetexample.test if the form rejected it. The planner filled every field and submitted. No created status appeared, the form stayed populated, and the email field remained active. From that visible evidence, it replaced only the email and submitted again. The site returned created CT001, and the server validator confirmed the record. Another task warned that 2 customer names began with Aster. The planner selected exact ID C103, changed its owner to Leo, confirmed the update, and left C101 assigned to Maya. Recovery and ambiguity had an 80-second median. The planner succeeded on all 12 runs in that family, but those were still bounded situations with visible cues and deterministic outcomes. The first attempt at run 7 exposed the only invalid result. The task said to sort requests by priority from highest to lowest. The interface offered priority descending, but my comparator treated the words alphabetically. That placed low before high. The planner selected the requested control and honestly reported the first visible row, R207. The semantic answer should have been R202, but the page itself contradicted the task, scoring that as an agent failure would have protected the benchmark instead of measuring it. I preserved the attempt in a separate void run log, fixed the priority comparator, verified that high now appeared before low, reset the environment, and assigned a fresh blind planner. The rerun passed. That void attempt is excluded from the 60 valid runs. It is not hidden, and it is not converted into a success. After 3 complete repetitions, all 60 valid runs passed independent validation. All 20 tasks were reliable under the frozen definition. Each one passed 3 out of 3 times. There were 0 human hints, corrections, rescue clicks, or restarts after a scored run began. There were also 0 critical errors. No wrong record changed, no disallowed origin visited, no unsafe action attempted, and no fabricated completion accepted. By family, navigation and retrieval was fastest. Form completion and filtering were in the middle. Multi-step state changes had an 88-second median. Recovery and ambiguity averaged the most time overall because they required more observation and additional actions. This is a clean result. It is also a result inside a laboratory, specifically designed to make success and failure observable. The median recorded duration was 72.4 seconds. The mean was 71.8. Runs ranged from 15 seconds to just under 156. Those numbers are orchestration wall clock time. They include planner turns, accessibility snapshots, handoffs, and the coordinator-operated browser proxy. They are not native browser agent speed, so I will not compare them with a person clicking directly or claim a time saving. The interface also did not expose a defensible per-run model cost. Cost remains unavailable rather than estimated from incomplete data. The evidence supports a specific conclusion. This planning setup was highly repeatable on a small, stable, synthetic interface with explicit task wording, visible controls, resettable data, and independent validators. It handled retrieval, forms, filters, confirmations, exact identifiers, and one designed validation recovery without human correction. That makes bounded internal workflows a promising use case. Especially when the action space is limited, the data is protected, and the final state can be checked automatically. It does not justify unsupervised access to arbitrary websites. Real products change. Labels disappear. Sessions expire. Permissions differ. Pages contain ads, private data, irreversible buttons, and ambiguous business rules that a synthetic lab intentionally excludes. I would use an agent like this to draft or execute reversible work in a sandbox, then validate the result before promotion. I would not let this benchmark authorize payments, delete records, send external messages, or make consequential decisions without a separate human approval boundary. The reusable lesson is not that 60 out of 60 proves perfection. It is that reliability claims become useful only after the task. Starting state, success rule, invalid run policy, and intervention count are frozen before the result exists. The next benchmark should make the environment less cooperative. Changed layouts, stale state, interrupted sessions, and tasks whose correct next step is to stop and ask. That is where a controlled success rate starts becoming operational trust. AI workflows. Tested under pressure,